All right, so skill 1, we're talking about angles, positions, and degree measurements. Now there's a bunch of vocabulary that we need to be comfortable with, familiar with, so that we know. First, let's draw a diagram of what our axes are going to look like. So here's my y-axis, and here's my x-axis. Now, if you have an angle that is in standard position, okay, so if we have an angle that's in standard position, what that means is your vertex, we'll say, of this angle, the rotation is about the origin. So I'm going to have a ray on my x-axis. And let's say that I rotate into the second quadrant. Okay, so I'm rotating in this direction. That's going to be an angle in standard position. So its vertex is at the origin. And then if I'm in standard position, that means that well, here, let's write it out together. So angle in standard position, vertex is at the origin. And if I'm in standard position, that means that my initial side, my starting ray, is on the x-axis. So the positive x-axis. So the initial side, which is your beginning ray. Oopsies, I don't need an arrow. Is on the positive x-axis. And your terminal side, because terminal is to end, right? It terminates. Your terminal side is the ray at the end of the rotation. Okay, so the ending ray, it's at the end of the rotation. So we rotated counterclockwise, which means this is a positive angle measurement. If I were to, and you know what, let's just say that this is about 125 degrees. Okay, if I rotate in the opposite direction, so I have an initial side on the positive x-axis, and I'm going to rotate clockwise. This is negative rotation. Okay, so if I ask you to rotate a positive 90 degrees, you're going to rotate counterclockwise. Negative degrees is going to be clockwise. So a negative degree is clockwise. Rotation around the origin. If it's a positive degree measurement, you're rotating counterclockwise around the origin if you're in standard position. Counter, I'm just going to erase that because that looks ugly. Okay, counterclockwise rotation. La la la, there we go. Okay, now if I ask you for coterminal angles are angle measurements that have the same terminal side. They share the same terminal side. And they are separated by multiples of 360 degrees. So an example would be 0 degrees, 360 degrees, 720 degrees, and negative 360 degrees. Those are all coterminal angles because 0 and 360 are separated by 360 degrees. 0 and 720 are separated by 720 degrees. Okay, so it's all multiples of 360, which is a full rotation. It's a full circle, so it's a full rotation around your origin. Think about if I am a circle. Okay, and this will come into play a lot more later, but if I'm a circle, I have a central angle. That means that my center of my circle, right, that's where the vertex is. So you can think of this, yes, the x and y axes very similar. If I'm a central angle, my vertex is at the center of the circle or the origin of my axes. If I'm an intercepted arc, okay, by definition, the intercepted arc is the arc between the ending of the rays. Intercepted arc. It is the arc where the rays intersect. So here and here. Okay, a little throwback to geometry again for you. So if I ask you to sketch an angle in standard position, the first thing you're going to want to do is draw your X and Y axes. I'm not going to expect it to be exact. I'm going to expect it to be as close as possible to the angle that was requested, okay? Standard position means that my initial side is on the positive x-axis and it's 100 degrees positive. So I'm going to rotate counterclockwise. Well, if I rotate here all the way up, that is 90 degrees. Okay, it's a 90-degree angle. So for me to be 100, I'm going to be right about there. And make sure that you always have an arrow to show the direction in which you're rotating around the origin. Okay, so we would say that that's approximately 100 degrees. Well, if it's negative 215, oh gosh, sorry, we're going to do the axes first again. There we go. And it's negative, which means we're going to rotate clockwise. Still, I'm in standard position, so my initial side is on the positive x-axis. I rotate 90, 180, and then a little bit above that is going to be our negative 250. Again, I have an arrow to show the direction in which I rotated, which is crucial. And there's my negative 250 degrees. Okay, so if we look at example 2, now it's asking us what's the angle measure given? Okay, well, let's see. If we look at example A, gosh, I have my initial side right here. I have my terminal side here. But the only thing I'm told is that that point is 3, 3, which means if I were to extend down an altitude, just for fun, why not? To get this x-coordinate, I would have had to have traveled 3 units on my x-axis. And then to go up to the point, I would have had to have traveled 3 units up the y direction. What type of triangle is this? Ah, yes, it is a right triangle, but it is also isosceles. And if I'm an isosceles triangle, that means that this angle and this angle, the base angles are the same. So if I am a right triangle and this is 90, that means that the base angles have to add up to 90 and they are the same. Yes, this is a 45-degree rotation. Nice. See? So we don't necessarily need to know what the angle is. We can deduce. We can figure it out. Okay, for example B, we are going clockwise, which means this is negative, a negative rotation. There's my initial side. There's my terminal side. I rotate 90, 180. Yep, this is a negative 270-degree rotation. Excellent. Nice job. Okay, so we also talked about what coterminal angles are. They are separated by a measurement of 360 degrees. Okay, and it's asking us which one's not coterminal. Oh, fancy. Okay, well, 750 is the biggest measurement, so I'm going to start by subtracting 360 degrees and see where that leaves me. 0, we need to borrow. This is old school, or you loving it? So this is 390. Okay, I'm going to keep subtracting because 390 is not on my list. But let's just see if I subtract 360. We get 30 degrees. Okay, that is on the list. So 750 and 30 degrees are coterminal. I'm going to keep subtracting 360 to see what happens. Oh, negative 330. So that means by process of elimination, negative 540 degrees is not coterminal with the other 3. They all have to be related in multiples of 360 degrees because that means they share the same terminal side. What does that look like? It looks like this. If I draw my axes. We'll do the first one in blue. Okay, so here is, and we'll say that this guy's blue, a 30-degree rotation. Well, if I take, and we'll do this guy in green. If I share the same initial side, right, so I'm right here, and I rotate around 360 degrees, and then another 720 plus 30, even though I have additional rotations, I still have the same terminal side, right? I rotated around 360, I rotated around another 360, so you're at 720 plus 30 degrees, you're at the same terminal side. If you were to rotate in the negative direction, only 330 degrees, I would end up right here. So again, the same terminal side. Okay, that's what coterminal means. Regardless of which direction you're rotating, you're still sharing that terminal side. Okay, so why does this matter to us? Well, has anyone heard of this unit circle shenanigans? What is that? Haha, unit. That means it is a circle whose radius is 1 unit. Okay, what's its purpose? Well, it's an organizational tool so that we can quickly know our trig calculations of special angles, and that is super important, special angles. Why is this important? Well, think about our multiplication tables, okay? We need to know super fast because we use it all the time what 9 times 9 is. Okay, 81. What's 10 times 12? 120. All these things that we know super fast. We don't have to go back and look at our multiplication tables. Well, that's the idea behind the unit circle. It's used in calculus often so that we know them and we know them well. We don't need a calculator to do them. Okay, so let's build our unit circle. This is page 2 of the notes. The only thing that I'm going to build with you today is the degrees. Okay, so I'm going to go ahead and switch back and forth between my colors. Well, we can say that this, our initial side at the positive x-axis is 0 degrees. If we rotate up to the positive y-axis, we have then rotated 90 degrees. If I keep rotating around my origin and I get to the negative x-axis, I have then rotated 180 degrees. Notice we're increasing in increments of 90. And then if I go down to the negative y-axis, we keep rotating. So this is 270. One full rotation in a circle is 360 degrees. Beautiful. Okay, so then if these are our special angles, remember, if I rotate up to 30 degrees, and then this is going to be 45, and the next one is going to be 60. There's a reason that I am using these colors. Okay, so I rotate up 30, another 15, another 15, another 30. If we follow that pattern, okay, then I would rotate continuing another 30. So 90 plus 30 is, 120. It is then added another 15, so we have 135. And then we add another 15 to keep following the pattern, and we get 150. And then another 30, and we get 180. Okay, so then if we add another 30, 180 plus 30 gives us 210. So at this, if I were to rotate around in standard position, I would have rotated 210 degrees. Okay, and then I rotate an additional 15, so now you're at 225. Rotate another 15 because that's our pattern, and we get 240. And then rotate another 30 and you're at 270 degrees. All right, 270 plus 30, because that's the pattern we're seeing with our special angles, we get 300. If we add another 15, we get 315. And then if you add another 15, you get 330. So ladies and gentlemen, here's our tiny introduction to our unit circle with the degrees rotating around the origin. More to come.